All right, so this is the prototype for our garage door opener and sensor. Everything will be controlled by this IR remote. This is something that will be attached to somebody's key fob or left in each of their vehicles. And basically the way it'll work is 1, 2, and 3 represent different car sizes. So if you press 1, that would represent our small vehicle over here. If you press 2, that would be our mid-size vehicle, which is represented by just the red car. The black tape is kind of a prototype limitation I had. And then if you press 3, that would be our larger car. Currently, all these values are set for average vehicle sizes for a smaller sedan, a medium-sized car, then a larger vehicle. And so that's how it operates for now. As for the garage length, it is set to something that would be an average garage length for the American home. But this ultrasonic sensor is going to measure the distance from the front of the car and then subtract that from the distance of the garage length and the car length, which is going to give you a rear distance and a front distance, which is then being tested amongst our code to ensure that your car is all the way good in the front and all the way good in the back. And then this remote will give you flexibility depending on what car you're driving to ensure that you are all the way into your garage as well as not too far back to run into the risk of the garage closing. So without further ado, we can test it out. So we would toggle 1 with our vehicle, then we would continue to move it in. And once it turns green, that means your car is good in the front as well as good in the back. And if it is good in the back and the front, then it should freely close and open, just like that. And if it were to be sticking out, then it would restrict you from closing the garage on your car, which is solving the very problem we have. And a buzzer would sound, so there's an audible way for the user to recognize that their car is in the improper position, as well as a visual with the LED. This potentiometer down here would allow you to change the frequency of it, just to give you flexibility of different noises and sounds that would best suit the driver in the car. The garage is functioning via servo motor. This is obviously not how garage doors operate in any country or in the US, but for this prototype, it was good representation and we hope to integrate it into the actual design of a garage. But for now, this is more of a representative example of how the programming of the Arduino would function. And we're hoping to interface it with the real garage going forward. However, if we switch our car, we would go ahead, press number 2, bring in the red, which is a longer vehicle compared to the green. As you can see, we're illuminated green, which means we should have clearance on the right side. Reminder, the black tape does not represent the vehicle, so it is fully into the garage. We maintain the freedom to continue to move forward until you approach too close, then we would go red again. So if we move back to the green zone, this would open and close freely as the user chooses. Now, because it knocked it in, there's a restriction there, but it works for that vehicle. And now going forward with the largest vehicle we have, toggle the large vehicle, ensure that this opens and closes freely. It does. As you can see, green light, clearance in the back, clearance in the front. So this should operate freely, opening and closing as it does. There we go. Now, if the car were to be in the improper position, just like the others, the passive buzzer should sound and the garage should not function, which is the case. Now, if we want to test the potentiometer capabilities, we certainly can. So we should hear a different frequency here, which we do. Now, there's no car. This should open and close freely, still making a sound as it goes down, just for user safety, and then opening in a typical fashion.